Alright, this is the video for Calc Prep 6 slope fields, and what we're going to do here is we're going to draw something called a slope field for each of the following differential equations. When you see this differential equations, you may also write down this word derivative. We're going to get into this into our next unit. And really the main idea of this is slope. So when you see this dy over dx, this is the derivative of y with respect to x. So really, though, the word we're used to is slope. Okay, so we're going to find the slope of the curve. It's represented by this equation. So it says graph the solution curve. The solution curve would be our y equals, okay, our original expression, and this is the slope expression. Okay, so we're going to take this expression, we're going to draw lots of little segments on this, and from that we're going to figure out what our solution curve should look like. Okay, so when I'm looking at these points, it's important that you know that I'm thinking about the x and y value. So like this right here, this is -3, -2. The x value is -3 right here, and in fact, then this whole column, the x value is -3, and since this expression only deals with x, I only have to deal with x. So what is -3 plus 1? It's -2. Okay, so what I'm going to do in this column right here is I'm going to draw a slope of -2. Okay, so -1 would be kind of like the exact diagonal, so -2 is just going to be a little bit steeper than that. Okay, so in this column I drew little segments of a line that's going to help me eventually draw this curve. Okay, so now let's talk about this column. This has an x value of -2, and -2 plus 1 is -1. So what we're going to do in this column is draw a slope of -1, and you're just drawing little segments because this is really only serving to guide us to this thing we're going to call the solution curve. All right. Now, in this column, we have an x value of -1. -1 plus 1 is 0. So drawing a slope of 0 is easy. That's just a little horizontal segment. And what you're going to find is there's going to be some symmetry happen. So in this column, we have an x value of 1. An x value of 0, and 0 plus 1 is 1. So this time we're going to do a positive slope of 1. And you can kind of see where the symmetry is happening. The symmetry is happening along this line right here. All right, and you're going to notice that this is just going to go up by 1 each time, and that should make sense since our slope formula was x plus 1. Okay, so I'm going to make this one a little bit steeper. I'm going to make the 3 even steeper. And I'm going to make the 4 even steeper than that. Alright, I'm going to go over here, I'm going to change colors, and what we're going to do is we're going to graph the solution curve. Now they're giving us a point, so that's a point on my actual solution, so 0, -1. I'm going to draw this in blue. Okay, at this point, the slope of my curve should be 1. Alright, and what's going to happen is, as I go this way, I'm going to follow these lines. And so I'm going to make sure that my curve has this, it's a slope, and it's increasing, and it's increasing, and it's just going to continue to go that way. As I go to the left, I notice that somewhere along this line, my slope is going to be 0, and so that's going to represent, just for a moment, a horizontal segment. And then as I go on, it's going to have a slope of -1, and then it's going to have a slope of -2. And this is just a sketch, okay? What shape did I just draw? I just drew a parabola, or a quadratic. What was the parent function of the derivative? It was linear. Okay, that's no coincidence. In fact, anytime your slope function is linear, okay, like x plus 1, or even if it had been 2x plus 1, even if it was more complicated, your solution curve you can expect to be a parabola. Alright, so now let's move on to the next one. So I'm looking at my slope function, okay, or my derivative, and it it's equal to 2y. This is not quite linear. All right, if it had been 2x, that would have been linear. All right, here though, I'm only focusing on the y, so on this one I'm going to actually look at the rows. Okay, so let's start with this top row. This top row is where y is equal to 2. All right, so what we're going to do is we're going to double that because it says 2y. So that's going to be 4. So everywhere along this top line, I'm going to draw a little segment with a slope of 4. So that's going to be a really steep little segment. All right, along this row, my y value is 1, so I multiply that by 2 and I get 2. And so that's not going to be quite as steep. It's still going to be pretty steep though, steeper than the 1. All right, what about this one right here? Here y value is 0. Double it, it's still 0. And I like 0 in slope fields. That's the easiest thing to draw. Okay, and then we're going to have a -1, which is going to make a slope of -2. And these little segments don't have to be exact, and you've probably guessed it, the last one's -4. There's always going to be some symmetry. And these little segments serve as a guide to graph my solution curve. So this time I'm going through the point 1 or 0, 1. All right, and I know at this point my slope should be 2, and as I go to the right it should get steeper and steeper. So it looks like that. And as I go to the left it should level out. And so what's happening here on this one, we see we actually have a horizontal asymptote. We have a horizontal asymptote of y equals 0 as part of my solution curve. Okay? So what do you think the parent function looks like? It looks exponential. Now I'm not going to get too into this because sometimes it'll look one way and honestly it'll be something else. We're just going to go with what we need for now. We don't have to know everything about slope fields. It's just an intro to slope fields. Okay, so if you look at number 3, it's a little bit more complicated because you have both a y and an x. All right, so we're not going to be able to do everything rows or columns at a time. Okay, but let's start with the easiest things to do. Okay, I'm going to start right here where x is 0. Why would x being 0 be easy to figure out? Because that causes this thing to be undefined. Okay, and undefined would be represented by little vertical segments. So everywhere x is 0, okay, it would have undefined, or you could think of the slope as being infinity. All right, likewise, everywhere y is 0, 0 over a number looks like this. And so it looks like I have a horizontal and a vertical asymptote here. All right, and we'll look at what that means later. Okay, but if you're thinking rational graphs, then you're on the right track. All right, so for everything else, we have to actually do the calculation. So we have 1, 1, but it's negative. So -1 over -1 would be -1. Okay. What about right here? We have 2, 1. That's going to be -1/2. And so it's going to get flatter, and as you guessed it, the next one's going to be even flatter. Okay, up here we have 1, 2. So this is going to be -2 over 1, which is going to give us a slope of -2. And then it's going to get flatter and flatter. And we're going to have some symmetry here. All right, so you can follow the symmetry or you can do the calculations. You're going to get the same results either way. I'm going to follow the symmetry. So there's symmetry over this axis. There's also symmetry over the y-axis. And so you can do the calculations like here. -1, 1 would be actually a +1. As the y value gets bigger, this is going to get steeper. But as the x value gets bigger, it's going to get flatter, the same way as on the other side. And so if you're like, how's she getting all these calculations so fast? I'm using symmetry and using the fact that a lot of these numbers are repeating. But you don't have to do that. You can just go through and do the calculations each time. The thing is, the slope field doesn't have to be exact. It just needs to be enough to guide you through the next part, which is taking your point 2 comma negative 1, okay, plotting that point, oops, not there, right here to negative 1. We know right here that, you know, it's going to be negative negative 1 over 2, which is 1/2, so it's kind of flat right here. It's going towards this asymptote, so I'm going to put an arrow, and then as I go here, it's going to get steeper and steeper and steeper, and it's going towards that asymptote. Here we have a vertical asymptote and a horizontal asymptote, and so this does appear to be a rational graph. We even have seen things like this before, okay, with rationals, those types of curves. Okay, so here we have number 4. We're using the same technique. We're taking the x-coordinate this time and adding it to the y-coordinate. All right, now there's no, it doesn't appear to be any horizontal or vertical asymptotes. But are there any other things we can do to make it easier on ourselves? In other words, are there 2 numbers I can add and it'll always be the same? Like, for instance, if you add along this line, okay, if we think about it, 1 minus 2 is 0 minus 1, negative 1 minus 0, negative 2 plus 1, and negative 3 plus 2, all of these give you a slope of negative 1. And these are not things you have to do in the beginning, but I'm showing them to you because it makes things easier, okay? This is actually creating a slant asymptote that we're going to see more clearly after we finished our whole slope field. Okay, also, are there any numbers that are going to add to 0? Are there any other maybe diagonal columns that add to 0? Yes, these numbers right here are going to add to 0. 0, 0, obviously, but 1, negative 1, 2, negative 2, negative 1, 1, negative 2, 2, those are all going to add to 0. And you're going to notice that there's going to be symmetry like this actually all along these diagonals, okay? It's going to switch up, but there's lots of symmetry here you can use. Okay, so I'm going to take a minute and I'm going to go through and finish off the slope field, and I want you to either use symmetry or just plug in points. Like if you're just like, I don't know where to start. Okay, pick a point. Here we have negative 1, 2. So negative 1 plus 2 is negative 1. So draw a segment with the slope of negative 1. Here we have 0, 1. Add that. That's a 1. Okay, here we have 1, 0. That's a 1. Here we have 2 minus 1. That's a 1. And here we have 3 minus 2. That's a 1. So there are ways to make this slope field easier on you. If you're not noticing it, you just go one at a time. 0 plus 2. Okay, so that's 2. And as you notice, as I go to the right here, it's getting steeper and steeper and steeper. Same thing here, steeper and steeper and steeper. Steeper and steeper and steeper. All right, over here, let's actually start with negative 2, 0. So that's going to give me a slope of negative 2. So that's a steeper slope. Negative 3 is an even steeper slope. And so it looks like I'm also getting steeper as I go to the left. Minus 1. That's negative 2. And here we have negative 2 minus 1, that's negative 3. Negative 3 minus 1, that's negative 4. Okay, so it didn't look quite right to me, so I just wanted to check it. And here I have negative 1 minus 2, that's negative 3, and it is just getting steeper and steeper. So you can definitely check your work. Your end result, though, should look like it's following some kind of pattern. You're not going to know where to start until you look at this point, 2, 0. So here we have 2, 0, and I know at 2, 0 it has a slope of 2, so it's pretty steep, and as I go to the right, it's going to get steeper and steeper and steeper. And as I go to the left, it's kind of hard to know where exactly this will go, but I know that somewhere it's going to flatten out. It may not go through that point, and you don't have to draw it that way. In fact, I'm going to purposely not, just to make sure you know. We don't really know exactly. We do know, though, that it has to bottom out, and it is going to trend towards this line, since everywhere along this line the slope is negative 1. That's going to be the end behavior here. And this does look like a slant asymptote. All right. Thank you.